Hello everyone, welcome back, and today we are looking at question 19, which is remove nth node from the end of the list. So we are given the head of a linked list and we want to remove the nth node from the end of the list and we want to return its head. So let's look at example 1. We can see that they are saying that the head equals 1. Now they're saying that the head equals 1, 2, 3, 4, 5 because, well, the head is 1 and this 2, 3, 4, 5 are all the nodes connected to the head. So when you see this, you just know that the head is 1 and this 2, 3, 4, 5 are the nodes connected to the head. Now, they're saying that we want to remove the second node from the end since n equals 2, which means we go to the end. This is the first node from the end, this is the second node from the end, and we want to remove this 4. So we remove the 4 and we return the new head, and which is connected to the new linked list, which is 1, 2, 3, and 5 with the 4 removed. Now let's look at example 2. We see that our linked list only contains one node and we want to remove the first node from the end, but since we only have one node, we want to remove that, and the output is nothing, right? Empty linked list. Now, they are saying that we have a follow-up question, which is, could you do this in one pass? Now, they are saying this because we can do an intuitive solution with 2 passes, and the plan for today is the following. I will explain both approaches. The intuitive way, we can say the brute force approach, and then we will explain it, code it out, and then we will go to the follow-up, explain that too, and code that one as well. Now, if you are interested in only one of these 2 parts, I will have the timestamps in the description. You can go to which part you want to see, but I highly recommend that you watch both to deepen your understanding. If that sounds good, let's get straight into it. So here we are at the blackboard, and now let's start with the question. Now, before we even go into approach 1 or approach 2, let's think about how do we normally remove nodes from a linked list. Imagine if we want to remove this node containing the value 4. What do we do? Well, if we want to remove this node, we need to go to the node right before it. In this case, we need to go to the node containing the value 3. Now, why is that? Well, because if we want to remove this 4, we need to take this pointer, right? And we don't want to point to 4 anymore. We want to go from 3 to 5. So, if we want to remove the 4, we go to the node before it. We take the next pointer of this node, and now we will point to the node after the node that we want to remove. In this case, nothing is pointing to this node and it will be removed. Okay? Now, when they say we want to remove the second node from the end, well, we need to know how many nodes do we have in the linked list, right? So that when we loop, we know on which node we need to stop. Now, we need one pass to know how many nodes do we have in the linked list. So let's start. Pass 1, let's count how many nodes do we have. We have 1, 2, 3, 4, 5 nodes. We have 5 nodes in this linked list. Now, once we know we have 5 nodes and we want to remove the second node from the end, well, what is 5 minus n? We know that n equals 2, so 5 minus 2 equals 3. And what do we notice that? Let's see. 5 minus 2 equals 3. Here is index 0, index 1, index 2, index 3. We are pointing to the node that we want to delete. So now do you see why having the number of nodes of the linked list makes this problem so much easier? Well, we can take the length of the linked list minus the n, which is the node that we want to remove from the end, and this will give us the index of the node that we want to remove. In this case, we have 5 nodes minus 2, since we want to remove the second node from the end. We get 3, and we see that 0, 1, 2, 3 give us this node. But remember that we said we need to go to the node right before it, right, in order to manipulate this pointer. So what do we do? Well, in a lot of the cases in linked lists, when you want to remove or you want to add nodes to the linked list, it's so beneficial to use a dummy node. Now in this case, we will use a dummy node, and for many reasons, and I will talk to you through them when we reach them. But we need a dummy node. It will contain nothing, and it will point to the head. The dummy node always points to the head. Now, instead of the indices be like this, now we will have it like this. Here is node 0, 1, 2, 3. And what do you know? We are right behind the node that we want to remove. Now we can loop to here. We can take this pointer and we can point it to the node after the node that we want to remove, and in this case the 4 will be removed. So let's write the code for this, and I will copy and paste the code for the brute force approach just to have some more time to explain the follow-up question. Okay, so let's do that. So here is the code, and let's see what the code is doing line by line. Well, the first line is saying, hey, create a dummy node, which we did right here. Now we are saying that, hey, the next pointer of the dummy node needs to point to the head. In this case, we know that the head of the linked list is 1, so the dummy next pointer will point to the head, okay? And now what is this line saying? Well, we are saying that we need a temp pointer in order to loop through the linked list. And so let's have it right here. Here is temp. And temp is starting at the head. We want to count how many nodes do we have in the linked list. And this length variable holds the number of nodes in the linked list. So as the code is saying, hey, let's count how many nodes do we have in the linked list. So while this temp pointer is not null, we will say length plus plus, since we are at a node that is not null and we need to count it towards the, number of nodes in the linked list. So we are starting here. We are starting at the head, and the head is not null, so length plus plus, indicating that the length now will be 1. And we are saying that temp equals temp.next, indicating this temp will move to here. Is this null? No, so we will increment the length one more time, and we will keep doing this until we reach is null. In this case, we would have 1, 2, 3, 4, 5 inside of length. So now length will hold the value 5. Good. So now we counted how many nodes in the linked list. Now we will say, hey, go to the node before the node that we want to remove. In this case, we want to remove this 4. We need to go to 3. And as you notice that, we said that if we take the length minus n, this will give us the index of the node that we want to remove. But since we used a dummy node, this will give us the index of the node that comes right before the node that we want to remove. Length is 5, n is 2, 5 minus 2 is 3, here is 0, 1, 2, 3. We are right before the node that we want to remove, okay? So now we need to loop from the dummy until, 3. So that's why we're saying, hey, temp equals dummy, indicating that take this temp variable, and now this will point to the dummy, okay? So we will take this temp from here. Now temp is here. Now we're saying for int I equals 0, I is less than length minus n. Well, length minus n gives you 3. So we will loop from 0 all the way to 3, and we will say temp equals temp.next. We will take this temp equals temp.next, temp equals temp.next, until we hit here. At this point, we are at index 3, and we are saying, hey, is 3 less than 3? The answer is no, and we break from this for loop, and we come here. We are saying, okay, we want to manipulate the next pointer. We are saying temp.next, which is this. We want equal temp.next.next. So if this is temp.next, well, temp.next.next is this 5, and now temp.next is pointing to the 5, and nothing is pointing to the 4, indicating that the 4 is deleted. And now we can just return dummy.next, because the dummy.next always points to the head of the linked list. You see dummy.next points to the head. Now we have the new linked list containing 1, 2, 3, and 5. And that's it. We can run the code right now. But you might say, hey, why do we need to return dummy.next, and why we can't just return the head? Well, let me ask you this. If we only have the linked list containing one node, and we want to remove that node, we know that this is the head. Now, if we want to calculate the length, we say, okay, the length is 1, and if we want to remove this node, 1 minus 1 is 0. So we go to the for loop for int I equals 0. Is 0 less than 0? No. We break from the for loop, and we say, okay, temp.next equal temp.next.next. We know that temp, which will be here, right, the same concept, temp.next is null, so null.next, we can't do that. This is null pointer exception. And that's why we say return dummy.next. Because if we have a dummy right here, which points to the head of the linked list, and if we have the temp right here, we say, okay, of course this is dummy, temp.next will equal temp.next.next. So now this will point to null, and we can return dummy.next. So let's run the code. Okay, and let's submit. As you can see, faster than 100%. So now let's go to the follow-up question. They are saying, can you do this in one pass? Notice that what we did is two passes. One pass, we scanned the linked list to see how many nodes do we have, and the second pass was we want to go to the node that comes before the node that we want to remove. So let's see how can we do it in one go. So let's clear out the code. Let's remove all of this since we cannot count how many nodes in the linked list. So let's delete this, and we don't need the length, and let's remove the temp. And yes, we will use a dummy node, but let's explain why before we do that. So let's comment this out. So now we need to 1, 2, 3. So now we need to remove the second node from the end, and we want to do everything in one pass. So how can we do that? Well, let's think. If we want to remove the second node from the end, we can create two pointers, right? Like a left pointer and the right pointer, and the width between these two pointers would be n. We said that n equals 2, right? So the left pointer would start at the head, and now we will have, okay, here is 1, here is 2, so the right pointer would start at 3. So why are we doing this? Well, let's see. When we go to the right, and now when the right pointer hits null, let's see what happened. The left pointer is pointing at the node that we want to remove. Well, is this magic? No, we said n equals 2, so the width between these two pointers is 2. So now when the right pointer hits the end of the linked list, or when the right pointer hits null, and since the width between these two pointers is 2, which is n, the left pointer would always be, or would always point to the nth node from the end. As you can see, the left pointer is pointing to the second node from the end since n equals to 2. So now how can we remove this 4, right? Well, remember that we just said in the first approach that we must go to the node before the node that you want to remove so that we can manipulate its next pointer. In this case, we must go to 3 and manipulate 3's next pointer, so now the 3 can point to 5. So how can we do that? Well, we will do something similar to the first approach. Let's create a dummy node. Here it is, and this will point to the head, which is what we did right here. So let's uncomment this, and now let me take this, right, and let me take this and put it right here, and let me take this, put it here. So we had this, right? We had the left pointer at the head, and we had the right pointer n nodes after the head. Since n equals 2, we go from 1 to 2 to 3. Now, let's put the left pointer start at the dummy node, and we will keep the right pointer n nodes after the head. Here is 1, and here is 2. So the right pointer stays on the same place. We just move the left pointer to the dummy. Okay, so now let's see what happens when the right pointer hits null. Here is this. Let's move it again, and let's move it one last time. And as you can see, when the right pointer hits null, the left pointer is pointing to the node right before the node that we want to remove. So now we can go to 3's next pointer, and we can point to 5, and in a sense we are deleting the 4, and again we will return dummy.next. Okay, so that's it. Let's try and code the solution out. So I have cleared out the picture again so that we can edit it as we code the solution. So let's start. We said we need a dummy node, So we create that, list node dummy equals new list node. And the dummy node must point to the head of the linked list. So dummy.next equals head. We have it right here. Now we have a left pointer and a right pointer. Well, the left pointer will start at the dummy node as we just discussed. So list node, let's call it left, equals the dummy node. Now we need a right pointer, so list node right, and this will point n nodes after the head. This is the head. Now n equals 2, so we'll go from here to here, that's 1, and from here to here, this is 2. But how can we do that? Well, we need a loop in order to do that. So let's start the right at 1, which is at the head, and now let's use a for loop to get the right in the correct position. So for int I equals 0, I is less than n, I plus plus, and we will say, hey, right equals right dot next. So right equals right dot next. Let's check how this works. We said the right will start at the head, and now, okay, is 0 less than 2? Yes, so right equals right dot next. Now the right is here, and I equals 1. Is 1 less than 2? Yes, right equals right dot next. So move it to here, and of course I plus plus. Now is 2 less than 2? No, so we break from the for loop, and we can see that the right pointer is at the correct position, which is right before the node that we want to remove. So now what? Well, now we said we need to move these pointers together until the right pointer hits null, because when the right pointer hits null, we know for a fact that the left pointer is pointing to the node that comes right before the node that we want to remove. So let's do that. So while the right does not equal null, we need to advance both pointers. So right equals right dot next, and left equals left dot next. Now, when the right hits null, we know that the left pointer is at the correct position. And now it's easy, just manipulate the next pointer. So left dot next, which is left pointer dot next equals, you see this? Here is the left dot next, which is this. This will point to where? This will point to 5. Or in other words, left dot next equals left dot next dot next, right? So here is left, and left dot next, which is this will point to left dot next dot next. And now the nothing is pointing to the 4 is deleted, and at the end just return dummy dot next. So return dummy dot next, and that's it. Let's run the code and let's submit. As you can see, faster than 100%. So now, what is the time and space complexity? Well, as you saw, we kept moving until the right pointer hits null, and we basically moved through all the nodes of the linked list. Assuming if we have n nodes in the linked list, the time complexity is big O of n. Now, we did not use any extra data structure. We used the linked list that the question gave us, which means the space is constant, big O of 1. I hope you guys enjoyed the video. Best of luck to you, and I will see you in the next one.